Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to another lecture of computer communication and networks. In this lecture, we are going to start chapter number 7 from the book of Data Communication and Networking by Behrouz Ferozin. This chapter is about transmission media. So, the transmission medium is basically something that comes after the physical layer. In the OSI model, we have learned the 7 layer, starting from the physical, then data link layer, then the network layer, and all the way to the application layer. So physical layer is transmission media is basically something that comes after the physical layer. As you can see in this figure, that what comes out of the physical layer goes onto the transmission medium, and that's what basically our signal is. So transmission medium by definition can be broadly defined as anything that can convey the information, anything that can convey, that can transport the information from the source to destination. For example, the people communicating on the dining table, uh, so the transmission medium for them is the air basically. When we talk on that landline phone like PTCL, the transmission medium is the wired. So transmission medium can be wired or can be wireless depending upon the situation. Now these are the types of the transmission medium. Transmission mediums are broadly divided into two categories. The first one is guided and the other one is unguided. Guided means there is some physical medium there to transport the information. Unguided means it is not physically present and signal is transmitted wirelessly using the electromagnetic waves. So in the wired category, we have broadly three further categories of the medium depending upon the type of the cable, like twisted pair cable. The first one is twisted pair cable, the other is coaxial cable, and the last one is optical fiber. So these are the three main types of cable that comes under the category of guided media. In unguided, though we do not have any physical medium, but here we have different frequency ranges in the wireless medium. Depending upon the frequency range, we divide the wireless transmission into three categories, is like radio wave communication, the microwave communication, and the infrared communication. We will now move forward and we will look into the detail of each communication medium. So starting with the guided media, which are those that provide a conduit form from one device to another, meaning that they provide something solid, something physical from one device to another in order to transmit the information. The common examples of guided media are twisted pair, coaxial cable, and the optical fiber. So starting with the twisted pair, now as the name suggests, the twisted pair cable will have twist of the pairs, meaning that the conductors in this cable are twisted together. So normally it has two conductors, and these two conductors form a one pair. So a twisted pair cable consists of a two conductor, or they are normally copper conductors, each having its own plastic insulation. As you can see in the pink color, these are the two cables two conductors. This pink color basically representing the insulation, plastic insulation, and the silver part is basically the conductor. So two uh, conductors having separate or on plastic insulation, and they are twisted together. Now the reason for twisting these cable is to reduce the electromagnetic radiation and the crosstalk from the neighboring pair, because there may be other pairs traveling surrounding these two pairs, so there may be a radiation or maybe a crosstalk. So this twisting basically improve the ability of the wire to reject the external interference. This cable is most commonly in today's local area network technology, and we will see what are the types and connectors of these cable. Now there are basically two types of twisted pair. The first one is UTP, unshielded twisted pair, and this is shielded twisted pair. As you can see, uh, more shielding is uh, done and at the STP in order to protect it from the external noise and external interference. This metal shield is also used to cover the twisted pair. This is just to protect the signal traveling inside the cable. So this one is more rigid, more solid, but obviously you have to pay the cost. And this one has no any external or extra shielding to avoid the interference. So this is more flexible and less costly or cheaply as compared to STP. But as far as performance is concerned, obviously this will give you more uh, good data rate and transmission experience as compared to UTP. So depending upon your choice and application, you can use any one of them, but normally UTP is sufficient to uh, cover daily data transmission. That is why it is commonly used in our home and offices. Now UTP cable has further subcategories. These categories are published by Electronic Industrial Association. So we have various categories of UTP, starting from category 1, 2, 3, 4, 5. Category 3, like for example, this chart is basically representing various things regarding the categories. Like this column is representing the name of the category, this column is representing how much speed they can support. Like starting from the category 1, they can only support speed up to 1 MB. Then 3, 2, up in category 3 we can support, this is the maximum speed that this cable can support. All right, so the third column is representing the repeater-less distance. Normally all the cables have the same distance, but with the same distance they can provide more speed. And then this is the cable type, and this is the main applications. Like category 3 is very important and uh, very much used in our telephone systems back in the era of modem communication. Normally cat 1 is simply for the plain old telephone system, not without internet facility, only voice communication. Category 3 were used to for the basic internet dial-up connections, and then normally we are using from category 5 to 6 and so on for normal for the internet nowadays. Now these are the two connectors for the category 3. Normally the connectors are known as RJ11 or RJ45. This RJ is known as registered jack. This RJ11 is basically used for the category 3 in the telephone wires, and RJ45 is used in the LAN. This has 6 pins, or we can say 3 pairs, and this has 8 pins or 8 pairs. 8 pins, 8 pins means 8 wires or 4 pair basically, and this has 6 pins or 6 wires, so 3 pairs, because one pair has 2 wire or 2 pins. So this is a one way uh, jack. You can insert this connector in only one way. You cannot rotate the connector and insert into the connect port. You can only insert it in a one way. Now this is the performance chart of this UTP cable. We have different gauges. We have different gauges cable, like 18 gauge, 22 gauge. These are the different variation of the UTP. So this figure is basically representing the frequency versus attenuation graph of the UTP cable, considering various gauges of the cable. It is in gauge, it is in inches diameter. So what you are observing from this uh, diagram is that here at the lower frequency range, let's suppose at from 1 to 10 kilohertz, or 1 to 50 kilohertz, or at most 100 kilohertz, the attenuation caused by the cable, UTP cable, is very minimum. It is 2 dB per kilometer. Means if you install this UTP cable of any gauge, of any type, if you are operating at 10 kilohertz, you will hardly experience 2 dB per kilometer attenuation, which is not too much bad as compared to what you are experiencing at higher frequency. So when you go at the higher frequency, the cable is not suitable, because at, let's suppose, at 1000 kilohertz, the attenuation is very high. So this UTP cable is more useful at the lower frequency range. That's why we have different types of cables, because each cable can only pass a signal with a good strength for a certain amount of frequencies only. Now the second type of the cable from in the guided media is coaxial cable. This is the cable that you normally used in the cable TV. But earlier this cable was also used for the networking. But nowadays UTP is more common as compared to coaxial for the LAN environment. So coaxial cable normally, like every cable, has one inner core, yeah, core conductor. This is core conductor. Then this core conductor is again protected by this insulator, plastic insulator. Then we have the second conductor. This second conductor is basically in the form of uh, shield, or you can say like net, net of conductors. This is the purpose of this is to absorb the external interference. And then we have another insulator that protecting the second conductor. And then finally we have a plastic cover. So this is the lookup of the coaxial cable. The main transmission is basically goes through this internal or core conductor. This second conductor is just to complete the circuit and uh, absorb any external interference. So now these are the different types. As I told you that this cable were also used for the Ethernet. So these were the two types, RG58 and RG11, were used for the internet or Ethernet environment. They are known as a thin net or thick net. And this is RG59 category, basically is used nowadays for the cable television. So coaxial cable categories are characterized by the RG, radio government. Each RG number denotes a unique set of physical specification. The number you have seen here, like 59 or 58, They are basically representing some physical specification, like what is the wire gauge of the inner conductor, what is the thickness and the type of the insulator, the construction of the shield, and the size and the type of the outer casing. Now these are the connectors, BNC connectors. Like in UTP you have RJ11 or RJ45 connectors. In coaxial cable we have different connectors, and for different category, like this is BNCT, a sort of term T connector used to connect the uh, two cables. So BNC connector is used to connect the end of the cable. Normally you see such type of connector in the end of the cable TV. This is the coaxial cable performance chart. As you see in the performance of the UTP cable, they were suited for the low frequency. Now let's suppose you want to operate at a high frequency, typically at more than 100 kilohertz or 1 megahertz and so on. So UTP cable will not support that frequency. For that purpose you need a coaxial cable. Now again in this figure you can see that uh, at frequencies from uh, zero point 0.1 megahertz or 100 kilohertz to 10 megahertz, the attenuation caused by that cable is very minimum. You can afford that. But at the frequencies higher than 10 megahertz and so on, the attenuation increases again. So for the very low frequency range, UTP is suitable. For the mid range, coaxial cable is suitable. And then if you want to operate at very high frequencies, then again the coaxial cable, not the UTP, are suitable. So for that purpose we have optical, yani for very high frequencies, when we goes to the very high frequency range, the electromagnetic signal becomes in the form of light, and optical fiber cable is basically used to travel the light. Now it has single conductor which is known as a core central part where the light propagate, and we have two, it is surrounded by cladding. Now the core and cladding are both of the same material, either glass or plastic, but their refractive indexes are different and adjusted in such a way that the light confined within the core only. So fiber optics is made up of glass or plastic depending upon the application. For the longer distance, optical fibers are of glass. For the shorter distance, they can be of plastic as well. As they used to transmit the light, they used to transmit the signal in the form of light. So I'm not going to go into the detail of the optical fiber because this is not the scope of this course. But optical fiber in nutshell is basically a type of medium, and it is not a copper cable. It is made up of glass or plastic, and the form of the signal is not electromagnetic. In fact, light is also form of electromagnetic, but signal is basically travel in the form of light, not in the form of electric current. And obviously optical fiber cable can support very high frequencies, as you can see from this chart, that the UTP cable is are supported for lower range of frequencies. Then we have coaxial cable, and then finally the optical fiber. Now the second category of the media is wireless communication. Now unguided media transport the electromagnetic wave without using any physical conductor. Now there is nothing solid, nothing physical types of medium involved. Rather we have only the free space. We have a air to communicate. Now depending upon which frequency range you are going to operate, we have different categories of the wireless transmission like radio wave transmission, microwave transmission, and infrared or optical transmission. This is a portion of the electromagnetic spectrum. It is showing that the whole electromagnetic spectrum is ranging from, let's suppose, 3 kilohertz to hundreds of terahertz for wireless communication. This range is basically known as a lower range of frequencies like 3 kilohertz to 1 gigahertz. It is used for the radio communication, and then we have a optical region where the signal becomes the light. In optical we have various categories like infrared, we have ultraviolet, or we have visible spectrum, and so on. So these are the propagation methods. Now, for example, if you are operating at a lower range of frequencies below 2 megahertz, like something here, or in a radio wave region, you will have a ground wave propagation, which means that when, like, let's suppose this is an antenna. So when the signal radiate from this antenna, it it propagate by touching the earth surface again and again and again and again, like this. So this type of it's like this. So this type of behavior, though there is no any physical medium involved, the frequency of the signal is such that, because the behavior of the earth and the behavior, the two factors are very important for the wireless transmission. One is atmosphere and other is your earth. So atmosphere and the earth behave differently at different frequencies. At lower range of frequencies, the behavior of these two, earth surface and the atmosphere, is that it confines the signal within, close to the earth surface. So the signal travels through by touching or by kissing the earth surface again and again. So this type of propagation is known as a ground propagation, and it is visible when you are operating at the 2 megahertz range. Now once the frequencies are increases, like from up to 30 megahertz, the signal start traveling in the upward direction. Why it start traveling in the upward direction? Because at this range of frequencies, the earth going to absorb the signal. So the signal is not trying to touch the earth surface, but it goes high in the sky. That's why told you that at different frequencies the behavior of the earth and the behavior of the atmosphere vary. At lower frequencies, the earth support the transmission. At higher frequencies, earth does not support, but and behave like a insulator. At the lower frequency, earth behaving like a conductor. So at higher frequencies from 2 to 30 megahertz, the signal start traveling in the upward direction, but at the atmosphere, at high altitude, we have different layers of ionosphere. These are basically the layer of ions. So these layer basically causes a signal to reflect back to the earth, and that's how this communication happened. So this type of wave, or this type of propagation, is known as a sky wave propagation, where the signal travels to the sky and then it returns back to the earth. Finally, we have a line of sight communication. If you operate more than 30 megahertz, now the signal won't have a upward transmission nor have a downward transmission. Rather, signal start traveling in the straight line. This is known as a line of sight communication. and it happens only when you are operating at very high frequencies. The problem with the line of sight communication is obviously you have to maintain a line of sight, meaning that the two antenna, the transmitter and the receiver, must have a line of sight. That's why the distance is very short at higher frequencies. This distance, the distance at the lower frequency is very much large, because you can see one antenna is here, other antenna can be here as well as. So these two antenna do not have any line of sight communication, because they have a ground wave propagation. The ground here, ground here supporting the transmission. Here also the two antennas are not in a line of sight position, and here the sky is basically going to support the transmission and reflect. But at higher frequencies, the atmosphere and earth became uh, behave differently, and signal start traveling in the straight line, and this is known as a line of sight communication or propagation. So as you can see that in wireless transmission or wireless guided media, though we do not have any physical path, but due to the behavior of the earth and behavior of the atmosphere, the orientation of the signal varies. It can be ground wave, or it can be sky wave, or it can be a line of sight transmission. So based on the frequencies, we have different categories of wireless transmission like radio wave, microwave, and infrared. Like this is in the gigahertz range, meaning that line of sight transmission normally for the radio wave means lower frequency range, and for that purpose normally omnidirectional antenna can be used. These are the applications that uses these frequency range like AM, FM, television, etc. Microwave region has high frequency range 1 gigahertz and onwards. Normally they employ unidirectional antenna or line of sight communication. Cellular phones or satellites normally use this. Normally our wireless LAN uh, routers also use or operate in this range. It is 2.4 gigahertz frequency. Now if you go beyond this range, we have optical region, and we have LEDs and lasers for that communication, but the distance are very short. These are the different bands, different ranges, different style of transmission. Like at lower range we have a ground wave transmission, at higher frequencies we have sky wave, and then at very high frequency we have a line of sight transmission, and these are the different applications. So that's come to the end of this chapter and this lecture as well as. Thank you very much.